Assalamualaikum and a very good evening to my madam Nur Haslinda. Today our group will be present about our topic that is Armstrong oscillator. Firstly, I would like to introduce our group member, which is me, Shazrizan Aizat bin Juansa, and the second one is Muhammad Hafizi bin Mustafa Azizul. The third one is Afiq Iqmal bin Amril, and the fourth one is Tivan Al Tirun Karasu. I will begin first. My part is about introduction, and the Armstrong oscillator, also called the Meissner oscillator, is employed to provide a sine wave output of constant amplitude and fairly constant frequency. The circuit is usually used as an area oscillator in receiver, as an sine source in signal generators, and as a variable frequency oscillator over the medium and high frequency range. The Armstrong oscillator used an LC parallel tuned circuit to ascertain the frequency of oscillation, with feedback being provided by a separate coil of proper polarity to sustain oscillation. It operates Class C with stabilized bias for application where waveform isn't important, and sophistication A where waveform is very important. This circuit was widely employed in the regenerative wireless, popular until the 1940s. In this application, the input frequency signal from the antenna is magnetically coupled into the circuit by a further winding, and therefore the feedback is reduced with an adjustable gain control within the electrical circuit. Therefore, the circuit is simply in need of oscillation. The results a narrow band radio frequency filter and amplifier. The nonlinear characteristic of the transistor or tube also demodulated the RF signal to provide the audio signal.
Assalamualaikum and a very good day to Madam and everyone else. I'm Afiq Iqmal bin Amril. Will present my topics for this presentation. Block diagrams. For block diagrams, there are many types of Armstrong's oscillator types of circuit. Out of those types of circuits, I only pick two of them. One is a simple type of Armstrong oscillator circuit, and the other one is a tune type circuit. The first circuit is a transistor Armstrong oscillator circuit schematics. It consists of inductor, capacitor, and resistor. The second one is a tuned circuit Armstrong oscillator. It uses transformer instead of inductors and uses adjustable capacitor. Now, I'll give this to the next presenter.
Assalamualaikum and hi, my name is Muhammad Hafizi. So now I am presenting Armstrong oscillator circuit operation. The Armstrong oscillator is used to provide a sinusoidal wave output with a constant amplitude and fairly constant frequency within the specified RF range. The Armstrong oscillator is also used as a local oscillator in receivers, as a source in signal generators, and as a medium and high frequency radio frequency oscillator. The Armstrong oscillator is used an LC tuned circuit to establish the frequency of oscillation. The feedback of the circuit is accomplished by mutual inductive coupling between the Tickler coil and the LC tuned circuit. Its frequency is fairly stable and the output amplitude is relatively constant. This is the example of Armstrong oscillator circuit using NPN BJT transistor. By connecting with L1 independently, the inductor L2 is known as a Tickler coil. It will provide feedback regeneration to the BJT's input. L2 inductively couples some of the signals in the output circuit to the input circuit. A parallel tuned tank circuit with L1 and C1 is included in the transistor's base circuit. C1 is a variable capacitor to change the frequency of oscillation. The resistor RB provides FOE equal to R, the correct amount of bias current. DC bias current flows from ground to emitter via RE, out of the base via RB, and then back to the positive. The value of RB and RE determine the amount of bias current, and generally RB is bigger than RE. The resistor Re provides emitter stabilization to prevent thermal runaway, and capacitor Ce is the emitter bypass capacitor. That is all from me. Thank you.
Good morning friends, my name is Devan. Today I am going to explain about the important formula with derivation of Armstrong oscillator. Before we get into the Armstrong oscillator, we just learn about what is oscillator. Oscillator means vibration. So in order to work as an oscillator, the oscillator must reach the criterion. The criterion will be called as Barkhausen criterion. So these are the Barkhouse criterion. In the Barkhouse criterion, there are two conditions. The first condition is the loop gain is equal to unity, which is 1. So the loop gain we call as AB. A means amplifier gain, the B is feedback gain. So the formula of the amplifier gain is V output over V input. And the feedback gain is V input over V output. So to get the AB, that is loop gain, we must multiply the amplifier gain and the feedback gain. So we finally get the answer is 1. So let's read about the second condition. The phase shift around the loop is 0 or 360 degree. So the two conditions are required for oscillator circuit are called as Barkhausen criterion. So let's do the next slide. So let's talk about the Armstrong oscillator. So in what condition the resonant frequency occur? You may wonder, when will the resonant frequency occur? So I will explain. Resonant frequency condition arises when the inductive reactance equal to capacitive reactance. So these are the formula derivation. So before we get into the formula, we just know about the what is XL, what is XC, what is FR. XL is the inductive reactance, XC is the capacitive reactance, FR is the output frequency. The output frequency is same as frequency of oscillation. So what is formula for XL and XC? In the slide I have written XL is equal to 2 pi FL, XC equals to 1 over 2 pi FC. So as I told you in the previous slide, that resonant XL is equal to XC, that is inductive reactance equal to capacitive reactance. In the condition, the resonant frequency arises 2 pi FL equal to 1 over 2 pi FC. So 2 pi F square L is equal to 1 over 2 pi C, and we get F square equals to 1 over 2 pi square LC. In order to get the F, that is output frequency, we must do the formula F equals to 1 over 2 pi LC 1 over 2 square. Okay. Let's go to another slide. So these are the summary of the Armstrong oscillator. So the frequency of oscillation depends on the value of inductor and capacitor in the tank circuit. So the Armstrong oscillator is a LC oscillator. It will be operate at the high frequency range. So in order to work in a high frequency range, we use the tank circuit. In the tank circuit, we have two components, that is inductor and capacitor. So let's talk about the relationship between inductive reactance and capacitive reactance. So as the frequency increases, the value of inductive reactance increases, but the value of capacitive reactance decreases. As the frequency decreases, the value of inductive reactance decreases, but the value of capacitive reactance increases. So that's all from me. Thank you.
The last topic for this presentation is application. There are two applications for Armstrong oscillator type circuit. One of them is to generate high frequency sinusoidal output signal. Armstrong oscillator can generate high frequency sinusoidal output signal because one of its capacitor slacks is earth. This gives a stable output frequency and output waveform. It also helps for the waveform to be detected by any other devices. For the second application, it is used in radio and mobile communication. An Armstrong oscillator can receive radio signals from an output signal generator. It can read narrowband frequency signal with adjustable voltage gain. This makes it hard for people to spy and read the signal without the right frequency. That's all from our group. Thank you and Assalamualaikum.